Okay, now I'm going to show you a few ways of getting data. First of all, let's find the data using this probe, which is going to give us temperature or pressure or anything at the point we want. For example, let me select this point. As you can see, temperature at that point is given. If you want to find temperature another point over that surface, you can see it's getting lower, 311, here 324. It's like a more than 10 degree difference. So this is one way, and you can adjust the position using these XYZ directions. Okay. One more, it's about vector. So let me turn off this. Location is going to plant 1, which I already defined, this one. And let's see. This is the velocity vectors. As you can see, higher velocity at the top, lower there. You can increase the size of those symbol size, so it will be much more clear for us how velocity change. If you want, you can zoom it here. You can see we have some circulations or almost zero velocity at the top. Okay, we're done with vector. You know how to draw plan. Let's draw a line. So if I want to draw a line, x can be 0.02, and let's put 0.02 for z direction here. For second point, again this one, I want to be a vertical line, so this one should be at the center, and this, let's check. Okay, this is my line. Do I need to decrease this to go, for example, this? Okay, this is my line, and I want to find what is the temperature over this line. I could increase, so in z direction, for example, 25, to move it a bit to the center. Okay, done. So this is the line. Half of it is inside the solid, and the other half inside our fluid, which is air for this case. Now let's open chart, and for the data set, first of all you need to select the type. It's XY axis, so I'm happy with that. Data series, you need to select where you want to have those data. I just draw a line number 1. I want to have data there, and if I go back, I would like this x-axis to be y. So x to be y, and y-axis to be temperature. So let's select temperature. I don't want to change the title. If you want, you can change those. And let's see. This is the chart view, and I applied. You can see the temperature gradient is very small here. Why? We have very small temperature change at this part, first part, and very large temperature change there. If I go back and turn on the counter to see why this happens, we can see clearly the area we have for the solid, it's almost red, and the temperature gradient is very small. But when it goes inside the fluid, we have orange and gradually moves toward the blue. So that is why here we can see this behavior for the solid and liquid part. And let me check other options. Okay, so this is the how to get temperature profile using the line. This simulation was transient simulation. So you may want to see what is the temperature of specific point as time passes, which is usually it's very important for the this type of simulations. To do that, you need to first create a point. Okay, I'm going to create a point. X, let's go with 0.02. Y again 0.02, and hopefully it is going to stay in the, okay, it's inside. I'm happy. If I want, I can move Z a little bit more. Let's see, too much, 2, 5, 2, 4. Okay, this is almost at the center. Let me turn off the counters. So I would like to know what is the temperature at that point. Let's make it more useful, because usually we're looking for the temperature at the tip of the fin. So let me increase Y to, for example, 3. Yeah, great. Enough. Now I'm going to draw a chart for that line, but this time it is going to be time dependent. So for the type, you have XY, which we used it. This time XY transient or sequence. It automatically understands, okay, X supposed to be a time. If I go and open data series, this time I want to select that point 1, which I just put the dimensions. For the X is time, I'm happy. For the Y, I don't want pressure, I want temperature, and done. Remember, because this is going to be a transient temperature, this result or Fluent is supposed to go read all the results we saved. So it is going to take a bit time. So let's apply it and see. As you can see, it's calculating, reading those data, and finding those points. But just based on the simulation result, we know temperature, first of all, should increase as time passes, and it should start from room temperature, which was 26.8. Okay, we have the results. You can see initial temperature is 26.8 almost, and time passes 800, 900 seconds, as you can see here, which we stop simulation. Temperature rise at that point to up to 52, for example. And you can export those data using this point. Let's go back. One more result representation. Yeah, let's go with this rendering, volume rendering. It is very nice for presenting your results. Let me check. For example, I'm going to show ISO view. Okay, volume render of temperature with resolution, for example, 100, and transparency 0.2. So your temperature for the fluid is going to be a little bit transparent and nice to view, and you can have like a volume rendered of the temperature contours there. Let's apply and see what I mean. As you can see, we have a 3D view of the temperature rendered there. So if I increase this transparency, you can see a bit more. See, it's less transparent, and it depends on the presentation you have. You're going to adjust this. If I decrease the number, it is going to be 100% color, and as I said, it depends on your preference. Okay, it's enough, and see you next time.